Okay, in this video we're going to take a look at some more examples of solving equations, linear equations. Example 1D, we have 2.1x minus 7 equals 23.83. So we got this minus 7 we got to take care of first. We're going to add 7 to both sides and get 2.1x equals 30.83. And then to get x by itself, if it's being multiplied by 2.1, just divide both sides by 2.1. And to two decimal places, 30.83 divided by 2.1 is about 14.86. Now, bear in mind, because we are approximating our answer, we are rounding our answer, when we plug it into the original problem, 14.68 times 2.1, and then subtract 7 from that, it probably won't come out to be exactly 23.83, but it should be pretty close. And we do get about 23.828, which is really, really close to 23.83. So keep in mind that if you're using an approximation to check your answer, you might not get it to be exact. Here it is. If we round to two decimal places, it is exact here. But again, it depends on the problem and how far you round off with your value of x. So x is about 23.83. All right, part E. We have 2 times the expression x minus 10 equals 4 times the expression x minus 5, and then minus 2x. So a little bit of distribution we're going to have to do first. So if we distribute, we get 2x minus 20 on the left, and on the right, when we distribute, we get 4x minus 20, and then bring down the negative 2x. So we can combine like terms on the right-hand side. 4x minus 20 minus 2x is 2x minus 20. And if we subtract 2x from both sides, we get negative 20 equals negative 20. So notice we don't have any more variables in this expression. Negative 20 equals negative 20. So if our variables end up sort of canceling each other out, what we're going to be left with are just two values, two numerical values. And they're either going to be true or false. So in this case, is negative 20 equal to negative 20? Yes, it is. So because we have a true statement here, that means our solution to this problem is x can be any number we want, any real number we want. We can plug it into our equation, and the left and right sides are guaranteed to be equal. So for instance, if we plugged in x equals, let's say 1, we get 2 times negative 9 is negative 18. 4 times negative 4 is negative 16, minus 2 times 1 is 2. And negative 16 minus 2 does give us negative 18. So when our variables sort of cancel out, we'll be left with either a true statement or a false statement. So here we have negative 20 does equal negative 20. That is a true statement. So x is all real numbers. And if you don't want to write out all real numbers all the time, there is a symbol for all real numbers. It looks like this weird R, capital R, that you can want to maybe, color in. So you might draw the letter R, write the letter R, and then shift your pen or pencil to the right slightly and then draw another R, and it should resemble this. So this is our symbol for all real numbers. All right, example F, we have 3 times the expression x plus 4 and then plus 3x equals 2 times the expression 3x plus 5 and then minus 2. So once again, we're going to start by distributing. 3 times x plus 4 is 3x plus 12, and then bring down the 3x. And then 2 times 3x plus 5 is 6x plus 10, and bring down the minus 2. Next up, we can combine like terms. 3x plus 12 plus 3x on the left gives us 6x plus 12. On the right, we get 6x plus 10 minus 2 gives us 6x plus 8. So we have 6x plus 12 equals 6x plus 8. If we subtract 6x from both sides, our variables are gone, and we're left with 12 equals 8. Now, this is not true at all, so it's a false statement, which means when you arrive at a false statement after your variables cancel each other out, your answer is going to be no solution. So there's no number that you could plug in for x and have the left side come out to equal the right side, no matter what. So no value of x is going to make the left and right sides equal, which means there's no solution. Now, if you don't want to write out no solution, just like with all real numbers, we have a symbol for that. We also have a symbol for no solution. It's the circle with a slash through it. So when you see or write the circle with a slash through it, it means no solution. Now, there is another way we can check our answers, and it's a visual approach, and that's to check to see where the graph of the left-hand side of the equation and the graph of the right-hand side of the equation intersect. So if we graph the left side of an equation and we graph the right side of an equation, the solution that we get is the x-coordinate of where they intersect. And the y-coordinate is going to be what we get when we plug in or check that value of x. So for no solution answers, like we saw in the last one, the graphs will never intersect. In other words, they'll be parallel. So it kind of makes sense if the intersection point is a solution, then no solution means they don't intersect. For our all real numbers answers that we got earlier, then the graphs are going to be one and the same. So if we graph the left side and then we graph the right side is going to sit perfectly on top of the left side. So there's an infinite number of intersection points if you draw one graph on top of another, which means any possible number you want to pick will be a solution. So for instance, here we have the graphs. I believe this is example 1a, where we looked at y equals 3x plus 4 and y equals 16. So in blue, I have the line y equals 3x plus 4. In red, I have the horizontal line here, y equals 16. We got for an answer for that x equals 4. Notice the intersection point, the x-coordinate of where those two equations intersect. The x-coordinate is the intersection point. The y-coordinate is what we got when we checked our value of x. So if we plug in 3 times 4 plus 4, we did get that y value of 16. So a very, very powerful way to help check your answers, and even to give you a preview of what your answers should be, is to graph them and see where they intersect. Now, that being said, in here, in this course, I will allow you to do that, but I'm not going to let you use the graphing calculator to do the work for you. So you will still have to show the steps to get something like x equals 4 in this problem. So please keep that in mind as we progress throughout the year. So, all right, that about does it for this video. Thanks for watching. I'll